brought to you by Accenture Extended Reality. This is Field of View.
Welcome, hello everybody. Welcome to Field of View, brought to you by Accenture and produced by AIXR. I am Nick Rosa from Accenture.
Hi, I am Daniel Colaianni from AIXR, the Academy of International Extended Reality.
And today with us, we have a very special guest coming from one of the most exciting companies around operating in the extended reality field. With a very interesting background in science and physics, a PhD in biomedical science, and a postdoctorate in neuroimaging.
And this one is, I think, Nick, this is going to be the one that's definitely for the people who like to nerd out when it comes to XR. This is going to be a little bit more technical, I guess, than some of our other podcasts, but it's really, really enlightening, even for me and for Nick, I think, to delve into some of the really nitty gritty of what makes XR happen.
Yes, we're going to talk about deep learning. We're going to talk about photorealistic rendering. We're going to talk about ray tracing in VR, and we're going to talk about the future of VR in the cloud and 5G. Please welcome Mr. Greg Jones from Nvidia. Hi, Greg. How you doing?
Hi, Nick, and thanks for having me. Thanks to Accenture and AIXR, and it's great to be here. So looking forward to the chat.
It's really exciting, I think, because I think, one of the things we do before we get a guest on is we do a bit of a deep dive into a few things, and there's so much, I think, to unpack within this episode that me and Nick are pretty excited.
Very cool. Yeah, and it's great to be on film, right? I've seen a lot of the podcasts, and you've got to, I'm hoping to live up to the other people you've done interviews with. So this is exciting.
Absolutely. We're thrilled to have you, and we can't wait to hear everything about what Nvidia is doing right now in the XR field and all the exciting things that you're preparing about the future. Greg, one thing, we usually ask for all of our guests to tell us a little bit about their origin story, about their past, and now they arrived working in XR. Would you like to give us an introduction about your career and what you've done to date?
Yeah, sure. So I think it really started. I've always been in science since the undergrad in physics, but really the road to XR started with my work in neuroimaging, because once you image and you put data to the neuroimage, the MRI or the CT scan or what have you, the next job is to visualize that data and to really start to understand it. And so when you say understand it, there's certainly an anatomical scan of a brain, but there's also electrical activity, metabolic activity, and trying to get all those data pieces wrapped in with the temporal part of it, so that you can actually understand what the brain's doing, what the disease is doing to the brain, what have you. Visualization became really important to me. So later on, after my postdoc, I joined a group at the University of Utah called the Scientific Computing and Imaging Institute. And I was the associate director there, and that's about a 200-person research group focused on scientific computing and scientific visualization. So really understanding scientific data. And what's fascinating about that research group, it was founded by Chris Johnson at the University of Utah, is that Utah was a founding force in computer graphics, right? Ed Catmull from Pixar came from there. Jim Warnock that founded Adobe came from there. Plus, just a host of others. Evans and Sutherland kind of started the department, and those are names that are certainly known to the XR community. So we spent about a decade and a half. I spent a decade and a half there. But what was really cool about the group was the students that came there. The students that came because of the graphics legend of University of Utah, and then they started working in scientific computing. So we had some phenomenal graduate students that invented quite a few really interesting technologies. One of those, Steve Parker, created a ray tracing program, and along with Pete Shirley, we wrote a grant, an economic development grant, to start a company around that. That company was Rayscale. It eventually sold to Nvidia, so the ray tracing company to Nvidia, and then we've got from that academic research group, there's probably 20 individuals that have graduated and come to work for Nvidia. So So one of those individuals, Dave Weinstein, the director of XR, was a graduate student there. He became the director of XR at Nvidia and gave me a call and said, hey, we should continue our work in visualization by driving Nvidia's XR program. So that's kind of the long-winded how I got to Nvidia's story.
So, Greg, you've got a PhD in biomedical kind of
science. Yeah, biomedical science. Yeah, I did. Was mostly in pathology and immunology, so looking at the physics of how the white blood cells work.
Oh, yeah. So where's the connection then between kind of the biomedical science into the tech? How did you make that leap? I'm interested.
Well, so in doing the biomedical, I used a bunch of lasers and spectroscopy to look at the biological elements. So I looked at how proteins combine to accelerate the accumulation of white blood cells, and I looked at that all with light and spectroscopy. And so my physics degree really came in, and then to analyze the data required a ton of computer programming. So all the tech was always there, right? And I don't think you can do much of a science background type of work without some tech behind you. So, and during the postdoc, we were doing really large scale neuroimaging in the late 90s, and storage was really precious, right? So these MRIs were huge. So we actually built a storage system that ended up being the basis of a company called Storage Tech's medical device for helping other departments do the same studies. So computers and where to put the data and how to massage the data is a piece of technology you can't avoid in these careers.
And after you graduated, you started your own venture, and you created an algorithm that is now using most of the MRI scan system in the world. Is this true?
Yeah. It's a pretty minor algorithm, but it's widely used. But it was widely used at the time. It's probably not widely used anymore. I'm sure they found.
I think Greg's just putting himself down here now. I think that's an incredible achievement.
And Greg, tell me a little bit about this move from the medical field to the technical engineering, basically, and applied mathematics and science. Was it something that you envisioned before while you were doing your physics and math BS, or when you were having your PhD in biomedical science, or is something that you realized that with time, understanding that technology could be a key to unlock a lot of potential in medical research and academia?
No, I had no foresight whatsoever, right? So the career I've chased is always, whatever is really entertaining and fun, right? I've not been very serious about my career. So I've just gone from one entertaining position to the next entertaining position, and what those happen to be, where you could kind of derive passion to do those things was my guide. So I didn't have any intuition of where I was heading, and what I get to say about that is every spot's been really fun and really exciting, and has been with a ton of passionate individuals to work with, and important topics of research or corporate progress. And XR is no different than that, right? XR is a really exciting place, a lot of passionate people, and with Nvidia, we get to help change XR for the entire world. So it's a really exciting time.
When was the first time, I guess, you heard about virtual reality or augmented reality or those things? And when, I'm interested, when was the first time you actually got your hands on your first ever headset or experience?
Oh gosh, we were using crystal eyes and things like that with magnetic tracking and 3D stereo big displays forever, right? So that with the Ski Institute. So Scientific Computing and Imaging Institute, we call it SCI. We're in Utah. It's a snowy place, so the Ski Institute. Everybody else calls it the Science Institute. So at the Ski Institute, we had big displays. We did stereo, and we played Doom. And then at night, and then during the day, we looked at scientific data. So it was a funny conversation when Dave called and said, "Hey, you should come to Nvidia and do VR." I said, "Wow." This was back in the Maxwell was wrapping up and Pascal was just launching. And so I said, wow, VR's horrible, right? It's why would I do that? And I went over to his house and he had a little Pascal based or a Maxwell based laptop, and VR Funhouse was playing in it. So I did VR Funhouse, a little piece of Nvidia software, and the experience was really amazing. It was like, wow, this is so much better than I remember. And so I joined Nvidia that day.
And from there, you started driving a lot of initiatives within NVIDIA, like VRWorks and other optimized algorithm and technologies for VR. Would you mention some of the project that you worked on?
Yeah, so I haven't, I would say I haven't driven any. The role I do. So NVIDIA's got phenomenal engineers, right? Just phenomenal, and over half the engineers at NVIDIA are software engineers. So you think of NVIDIA as a hardware shop, but software is a big deal. And so the team I work with, our job is really to bring back the market information. This is where the market's going. These are the tools that could help. And so in the early days of VR, remember VR in head-mounted displays is probably 2015-ish when the GPUs were strong enough to hit 90 frames at the resolutions that we're talking about, stereo, left eye, right eye. So that's what Maxwell, Pascal, I think in terms of NVIDIA GPUs, of course, but Maxwell, Pascal, Turing, and now Ampere. So that's only 4 generations of GPUs that have seen that were VR ready, as they say. So in the early days, VR ready needed a lot of help. It needed lens match shading. It needed, VR SLI to get big data sets and really produce that 20 millisecond latency and the frame rates you needed to have a good VR experience. So the market really helped define all the VRWorks packages, and then later on, and we always thought it was going to be an impossible feat, but no one likes being tethered. And on top of that, the tethers, you have all the lighthouses and such, and just the complexity of getting into VR, which has been a market drawback for ever since VR to the headset started. But the thought of streaming VR seemed impossible. And then the engineers at NVIDIA came up with CloudXR, and the market is, taking all-in-ones and letting them get to a really heavy-duty GPU and get, beautiful graphics in that headset, in an all-in-one headset, is a really exciting piece of software. So the engineers have listened to what we've brought back from the market and have responded and created some gorgeous stuff for us.
I'm interested that, I mean, so in those early days when, you've joined NVIDIA and I'm working with VR now, how do you even begin to push something like virtual reality into the market and get that feedback back? Because I think even in 2015 it seems like an age ago when it comes to this technology and seeing how far it's progressed. And during that time there must have been a lot of naysayers to the technology still, but compared to these days as well.
Yeah. So one of the things we do is we really get in with the people using XR. We really, we have weekly conversations with groups like HTC and Oculus and Ericsson and Qualcomm. But some of the most important work we do is going out and talking with the customers. For instance, Pete Pang, one of the team members who came from Toyota as a designer, he came into our VR group. He and I take a trip with our German account managers and our dev tech lead. We take a trip to Germany once every year and a half, and visit Mercedes, Daimler, or those are the same thing, Daimler, Audi, Volkswagen, Porsche, the Stuttgart Kia design shop. And we sit and chat with the designers and say, what are you doing in VR? What's good about it? What's bad about it? And we really kind of take those pain points and the advantages that they tell us about, and try to work with our engineers to amplify the good things and solve the bad things. So it's really, I tell the team all the time, it's baby steps of figuring out exactly what the market needs to move to the next level. getting that from the customer and translating it to the engineers.
So what do you think the first difference was between, I guess, the approach that you had to take when you first were brought on compared to today?
It was harder to find people doing VR, right? With any seriousness, right? There were a lot of silly VR things out there at first. Experiences that were I don't want to talk anybody's experience down, but there were experiences you went, wow, I don't think there was ever a need for that experience to be created. So I'm not sure that's going to be a growth area for VR. And now if you look at it, engineers, designers all over the world have found that VR is a great way to save time. It's a great way to collaborate. And as things get more and more photoreal, it's going to replace, one of the gold standards we have is, can we replace eventually the clay model in automotive? And when we get that reliably replaced with virtual reality, we'll have really made a gain. And I'll say, I mentioned this earlier in our prep. I was doing the Vario most recent headset experience and passed through VR with a Volvo car in the room. And for me, it was the first time that I actually fell for the VR trick. I thought the car was actually there for a second. So the immersion into the data with that car sitting right there, I actually believed I was looking at a car that was actually in a room. And when I went out to touch it and it wasn't there, I was really surprised.
I wanted to ask you about the current state of VR. We talked about your past. We talked about the past of VR, the beginning of the new VR explosion that started in the mid-2000s. My question for you is, right now, do you see more and more clients ready to scale the technology, the adoption of the technology? And what is, from your point of view, the real secret sauce in order to scale this kind of technology inside the enterprise?
Yeah. So I think we've seen a glimpse of the real secret sauce, right? So I looked at some of the VR data over the past couple of years, since about 2018, 17. And what you see in VR headset sales is you see an annualized growth rate of, roughly 30%. And so, robust growth. You'd take that if you could pick a stock that gave you 30% annualized, you'd do it. So it's a good, robust organic growth market. But from 2019 to now, what we're seeing is a sector of that market growing at like a 90% annualized growth rate, right? It's a pretty small data sampling, but you've got one sector really growing, and that's that all-in-one, right? And most of that's the Oculus Quest, and of course the HTC Fusion or Focus Plus. But the Quest 1 really took off, and reportedly the Quest 2 is selling even better. So if you take that ability for an individual to get into VR easily, right? I don't have lighthouses, I don't have a tether, I put the headset on, I'm in VR. That seems to be the inflection point of wider adoption. And so we took that as a clear signal that if we can get, your GPU, your on the Qualcomm, the Oculus Quest 2 has a Qualcomm XR2 in it. And it's got an Adreno GPU, which is a great GPU, but it does have a lack of power, right? You're running on a battery on a head, so you can't put a 300 watt GPU there. But it's got a great decoder. It's got a great set of other things doing that it does on the XR headset. So if you can stream XR from a 300 watt GPU from an Ampere A40 or A6000 to that headset, and overcome the latency problem, you've got an experience where now that ease of use of the all-in-one is right there, that inflection point. But now we can also look at getting, world-class graphics to that headset. So it's seeing that inflection point come about with the all-in-ones is really exciting.
So you believe that cloud-rendered XR and pixel streaming through 5G technology and Wi-Fi 6 is the key component for mass adoption of the technology?
Yeah, absolutely. I have no doubt, and same with AR, right? So getting, we don't have any headsets that have garnered wide adoption yet, but the AR puzzle, I think the same thing. Getting, first off, beautiful graphics to those headsets, and to the handheld devices, over Wi-Fi 6 and 5G, where you can have multiple people. One of the problems with Wi-Fi 5, let's say, is as you get too many people on, the jitter of the network goes way too high, and you end up with just not being able to have good experiences with multiple people. So hopefully this multiplexing of the signal that 5G and Wi-Fi 6 offer will help us get more individuals in a room on. But you think of the graphics, but also think of, if I'm in an AR experience, I want, a back channel data flowing back. I want some imagery going back. I want artificial intelligence contextualizing that image and then giving me contextual data about the scene I'm in. And we want that for both, AR and VR. So now I'm going to do graphics. I'm going to do inference. I might even do some deep learning, some image analysis. That's a lot of load, and that needs to be done back in the data center.
Well, I guess one of the problems that I have at the moment with, I guess, when we want to approach CloudXR and things like that is a lot of talk around 5G technology, right? But I guess that the biggest challenge that I actually see in the short term, at the very least, is the fact that you've got a lot of telcos out there who are pitching 5G to the general consumer kind of public, and really that 5G isn't actually where 5G is meant to be, if you know what I mean. I mean, how long are we actually away? I mean, I've got a Wi-Fi 6 router right here, so that I can use that today. So realistically, what are the actual stepping stones for your average consumer or even your average kind of business to be able to get to say from, okay, I'm going to be using CloudXR on my Wi-Fi 6 router through to, okay, I'm going to be in the middle of a park connected to 5G, watching something on my VR device or AR device?
Yeah, so there's some capital investment, right? There's some CapEx hurdles. And so if you think of the United States, I'll just use them as an example, and I've looked these numbers up and I forget them every time. So these take these as approximations. But there's roughly, I think, 200,000 or 300,000 cell towers in the US right now. The 5G rollout, when it's complete, there's going to be like 700,000 or 800,000 towers in the US for the complete 5G, the high bandwidth, low latency 5G that we all think about. So the capital investment to get there is pretty significant. And that capital investment is the same for headset companies. So, headset companies to build a all-in-one and to get a 5G modem in there, that's a pretty significant investment. So we've got a little chicken egg problem going on with the CapEx needed by both the device manufacturers and the telcos. So what we're seeing is groups like Qualcomm coming out with their reference design with an XR2 with the 5G modem. We'll be doing some proof of concepts with that and with the Ericsson 5G network. Those proof of concepts will end up happening in dedicated networks, right? On-prem with data centers streaming 5G. And then from there, you'll start seeing public network. Like right now with CloudXR, we can stream from an Amazon Web Service data center, and you're going to see a 30 or 40 millisecond network lag. We can accommodate that lag with the way we build the late latch on the CloudXR, and you can stream that to a Wi-Fi in your home and play Alex Half-Life from an Amazon web server. We've done that experiment. One of the Amazon guys did it and had a great experience.
Let's say to an Oculus Quest 2.
Yep.
Without the need of any computer, without the need of any tethered device, you can do everything wirelessly.
Yep.
Which is quite phenomenal. Sorry, I just wanted to point out that the streaming goes straight to a tetherless device that is with an ARM-based chip that usually can't run that kind of high fidelity graphics.
Yeah, and shout outs to William Kennedy and Leo Chen at AWS. They built a machine image with us with CloudXR on their servers and tried that experiment and had a great Alex Half-Life experience. So we're working on what that means to bring that to market, to make that available. I don't think that's the consumer play, right? Because it seems hard to think of consumers building that setup. But that's the start, is getting those streaming on kind of existing infrastructure, then thinking with the telcos.
Do you ever foresee that coming onto something like GeForce Now?
I don't see how it's avoidable. I don't know, I can't give you any time schedules or anything, but streaming immersive experiences will be on all the platforms, right? That's one of our goals with CloudXR. That's why you see announcements with us from Ericsson, because that's the 5G. That's what 5G MEX will be built with. Our announcement with AWS, our announcements with Qualcomm are looking at all the platforms that will eventually be consumer platforms for streaming immersive content.
And now we talked about the immediate future. What I would like to talk about is the future in 10 years from now. Nvidia has been pioneering machine learning algorithm and deep learning algorithm in order to increase the resolution of images with the DLSS and also with ray tracing, that without the kind of deep learning algorithms that you implemented in the RTX cards wouldn't be possible. Do you see those two technology to be implemented also in the VR world? If yes, can you tell us more or less when this is going to happen?
Yeah. So ray tracing for gaming, we saw that really launched with Turing, and it's a step up, significant step up with Ampere. The VR problem is we're back to that 90 frames per second with too high resolution frames having to be generated. So it's really close. I've seen some experiments. It's going to take a combination of a variety of things right now, and we'll see. The GPUs are going to increase in power also. So we'll see a couple things happening. GPUs, next gen will be better and better. But also we'll see things like foveated rendering, so eye tracking and the all-in-ones, being able to just high sample that foveal area and then lightly sample the outside. That's especially important with ray casting. So we'll see foveated rendering help, and then taking those images, and before they're actually ray trace complete, deep learning those and inferring what the right image will be before you have to finish your ray tracing convergence. That those three things, predominantly, and other stuff will bring that up. And I think that future is pretty close, actually. I don't think it's far off.
Can we say a couple of years from now?
Oh yeah, a couple of years easy.
Also, that's very much like from a VR perspective. So what's Nvidia's role within AR, especially when it comes to this AI and kind of deep learning as well?
Yeah, AR to me is they're almost the same thing. They're almost the same thing in many ways. The optics of AR are quite a bit more difficult because you have that opacity in the mixing with the scene, the real life. But if you think of the AIs, they're going to have really similar responsibilities. I like to think of them as collaborators with certain responsibilities. They're going to have to jump into the scene, whether it's a virtual scene and they can look at the scene graph, or if it's a live scene and they're looking at the real world, they're going to help understand that world and take that back, process it. So we'll give them, CloudXR will be the kind of their viewport into the virtual world and their viewport into the real world. And then through CloudXR, they'll give us contextual data about those worlds. Like in the virtual world, you could imagine an architect or a construction person working with an architect. And those contextual pieces are where things sit, measurements, completion done, all that. In a real world, you can imagine those things are, where am I actually? Tell me where I need to go next to do whatever I'm doing. Tell me who this is that's approaching me. All those types of contextual things about our environment, be it a virtual environment or a real environment, will be where AIs really come in. And then our interactions with them will be, instead of using a controller and clicking up a clunky UI that jumps in the way of the data scene, you'll put that controller away, they'll recognize your hand motions, and you'll have a conversation about the data with them, right? Because think of in a virtual environment, they'll be in the scene graph, they'll understand the scene graph, they'll understand the context of the scene graph, and you can have, you're a designer looking at a car, that car is well understood by the AI, and you can say, make that red, and the AI will understand you're looking at the fender, and it will say, which red do you want? We have a palette of multiple reds, and it will turn the fender whatever color, and that will be just a natural discussion, and that will be your UI for VR. So that's where I see it going, in the next decade.
And it seems that Nvidia has all the piece of the puzzle in order to do that, because you have Jarvis, which is your natural language processing API. And then obviously you are pioneering all the segmentation for self-driving cars with the Jetson Nano and all the microcomputers that are on board on multiple cars right now and will drive the self-driving car revolution. But it also seems to me that there's another very fascinating aspect of machine learning and deep learning that will evolve more and more in the next following years, which is the programmatic generation of worlds and 3D assets based on machine learning algorithms. So being able, for example, to recreate programmatically a city or a scenario of a city or a video game, or as you said during the call that we had before this recording, eventually being able to customize the movies and the TV show that you're watching with faces of you or your friends or people that you love or your favorite actors and so on. This is fascinating. And when do you think that we're going to start seeing the first implementation first on for the enterprise and eventually commercially of this kind of technology?
Well, I think internally, you're seeing that in a variety of places. Internally, we certainly see it with the Drive team, where they're driving, millions and billions of miles in simulated environments and not having to wait for people to actually drive those to train the AIs. So it's kind of a give and take. The more data we have, the more data we can, more annotated data, especially that we have, the more of that we can give to the artificial intelligence, to the nets, and the better the simulations become, the more probability complete they become. So it's really an exciting time to think of, stepping from, and these are all major lifts, right? As a business development person, it's all easy to talk about, but then developers have to actually do a ton of work. But the idea of an AI understanding the scene graph, in the next step is the AI creating the scene graph, is really an exciting. Those will be inflection points in and of themselves for the XR experience, and XR will be, Drive. You'll have XR experiences in your car. Your car will be having an XR experience as you ride in it, and so it's really a fascinating world when we think of combining them through these edge compute and onboard compute AIs working together to understand the world we're in, understand the virtual worlds that we play in or design in, and to bring new ideas to those worlds with us.
There will be an inflection point in also the way that those machines will evolve and those algorithms will evolve, because with the creation of synthetic data lake that are used to train the machine will learn by their own data, basically, and they will able to create more data from there and become more and more smarter, let's say.
Greg, for those like developers that are listening to this podcast and that are making content and stuff like that, I mean, I'm interested both from a perspective of keeping this trail of thought of AI and this area of things, and on how that's going to impact them as developers for creating content. I'm interested to hear that, but also I guess like right now in this very day and age, as a developer, like how can they be utilizing Nvidia resources essentially to make their jobs easier at the moment?
Yeah, great question. Well, watch our announcements. We've got GTC coming up in April. And so I'll put a plug in for our GPU technology conference. That's focused at developers. And we really try to work with partners especially and customers to highlight the current technologies, how they're being used. AI is the big focus of GTC. So I would encourage everybody to look at the sessions in GTC. I think we had 50,000 people at the last one. We're expecting similar numbers, I'm sure. And so that our web pages are full of interesting stuff. But so I just had an employee join the team about a month ago or 3 months ago, and he's going to be an XR person working in the XR team. But the first thing I asked him to do was go ahead and go through the Nvidia Deep Learning Institute to get up to speed with where we're at. So I would encourage, any developer that's heading in this area to jump into something like NVIDIA's DLI and get a taste of where AI and deep learning is right now. I think it's going to be a really important part of the ecosystem for literally every developer I can think of.
Greg, one of the things that fascinates me the most is an experiment that I saw. Actually, I think that was an NVIDIA white paper of a technology that was able to recognize hand-drawn pictures and create photorealistic image from that hand-drawn picture, any kind of picture. So if you think about the kind of graphics that you can get from even cell shade polygons, do you envision that in the future, this kind of technology will be applicable to moving images? So for example, a VR headset will create a flat shade image of a person, and that person can be represented as photorealistic in movement.
Yeah, I mean, how could it not? But yeah, Gauguin is the thing you're I think that's what it's called, the NVIDIA tech, that is really fascinating to draw with. And I've done it at conferences a couple of times, really fun to interact with. But those types of ideas, right, it just takes the big barrier to entry. There's certainly development, but the hardest thing, and you mentioned it earlier, is creating the data and the annotated data to train the neural nets, the DLs. So really that the DL's the heavy lift. And so if you have a team that's willing to build the data, the annotated data, train the neural net, anything seems possible in that space. But there is, it's worth knowing that the data is the hard part, getting the data in, getting it prepared, getting it annotated. And those are certainly tools we're working on, and the rest of the ecosystem is also.
That's fascinating.
That's great. Well, and then okay, so we've covered AI, deep learning, and CloudXR, all of these things. So really, I mean, in your personal opinion, what do you think is the actual next big thing for XR? Like, if you were to think of the milestones, if you could actually, I'll ask it like this: if you could lay out 3 different milestones that XR needs to hit to be ubiquitous in every sense of the word, what would they be to you?
Yeah. Okay. So 3, and they're kind of intertwined. We need a really comfortable, good-looking apparatus to view the data on, whether that's a headset or a handheld, and those optics are going to be tough, right? We're starting to see light fields and things like that come out. So a lot of people are ideating, experimenting, working in that area. So I think the displays will improve. That'll be a slow convergence. The ability to stream from multiple edges will be important, and more importantly, like CloudXR right now, one of the limitations that will keep it in data center and make it harder to go out to public is I can get 2, maybe 3 VR users on a single GPU on a lot of different VR applications. Maybe a few more on let's say an Ampere 6000, right? I can get two people on an Ampere 6000 playing a pretty complex game, and the GPU has plenty of room. To get 3 or 4, I've run out of encoding, right? So I've got to make a frame, encode that frame, and they're pretty high frequency, and they're going to go up in resolution. So I need a more scalable way to deliver XR from the edge to get those GPUs affordable for a broad class of users. And so that means right now we think of split rendering as I make a frame in the cloud, and then I encode that frame and send that frame to the headset. The headset decodes it and warps it to fit with the lag I've had in getting that frame to the headset. So split rendering is right now make a frame and transport a frame. It will probably be a more shared set of roles, similar to what Verizon has done some really nice work, their environment group, in doing rendering on the phone, and rendering on the edge, and combining and basically compositing those two renders at the phone. And so that kind of split rendering will probably be, as that comes along, you can think of, let's do a global illumination. Let's say there's a large group playing a game, 10 people. I can do a global illumination. I can ray trace that, use that same global illumination for everybody, do raster for all the individuals. And so splitting those render responsibilities to different compute places, different GPUs in different places, some on the headset or the handheld, some in the cloud, some in the far cloud that's maybe a few more milliseconds internal, and I don't need it that quickly. Same with the AI. Some AIs are going to have to be low latency, some can be longer latency. So the disparate compute type of idea, where I have, the right value of GPU doing the right thing to get the economics into place to where everybody can use this. That's a lot of the work that has to be done is the split rendering or disparate computing.
Could you, just for like a dummy like me, I mean, could you explain it like I'm a 5-year-old, I guess, so for like CloudXR to work, what's the actual process? So let's say I'm at home, I have my headset, and then I load a piece of content. What actually happens in the background for that to work?
So what happens is you've got a server somewhere, and it's got a beefy GPU. I always think of RTX 6000s as kind of a landmark, or the A6000, the new Ampere. And so your VR application sits on that. And right now, the way CloudXR works is basically built on SteamVR. So your OpenXR or OpenVR application makes a frame, hands it to our SteamVR based driver on the server. That SteamVR driver encodes the frame. So the nice thing about that is the VR application hasn't had to change at all, right? It's the same VR application that sits on your desktop and runs VR, because it's just talking to SteamVR. So we take that frame, encode it, transport it across the network. And in this case, when it's being transported across the network, we're using the streaming libraries, the base streaming libraries of GeForce Now, right? So we're borrowing some technology from the GeForce Now team. They've been working on that streaming problem for a number of years. And then we have the SteamVR library we've built. We have that sitting on the headset, let's say. And so we've put a SteamVR library on the server and one on the client. That SteamVR client now sees the frame, decodes it, and hands that frame, just like SteamVR would do at any other given time. SteamVR hands that frame to the headset. The headset says, hey, I called for this render a while back. I've moved since the render. Will you do a quick warp for me to fit my current head position? And people call that asynchronous time warp, asynchronous or late latch. So that last millisecond warp is done on the client-side GPU. That warp takes anywhere from 1 to 3 milliseconds. So the user thinks, as far as the user knows, they've got effectively a 3 millisecond old frame in their headset. And so you've beat that 20 millisecond nausea-causing lag, and you've actually covered up, if you think of all the steps in there, we've got, let's say we've got 10 to 15 milliseconds of render time. We'll call it 10 just to make the math easy for me. Let's say I have 5 to 10 milliseconds of encode and decode. So let's go 15 milliseconds of decode total. So I'm at 25 milliseconds. Let's say my network is 10 milliseconds. So I'm at 35 milliseconds. We have a buffer in there for jitter, which is a minimum of roughly 8 to 10 milliseconds. So now I'm at 35, 40 milliseconds. And then I've got that last few milliseconds to do the warp. So I'm up in the 40, 50 milliseconds, even with the 10 millisecond network. And that would absolutely make you sick if it weren't for that late latch hooking the frame to your most recent head position. So that's the secret of CloudXR is there's two technological leaps and then a ton of work in between. One is moving late latch onto the client-side device, and the other is the streaming protocols that we use from the GeForce Now team. And those are the two, technical pieces, and then tons of coding.
How much processing power is actually being done on the client-side GPU at this point in time?
Very little. It's doing decode and that last millisecond warp.
Okay.
If you think of the Adreno and the XR2, there's plenty more work we could do there, right? So it's got a lot of capabilities that particular way of streaming isn't using. So there's a lot of work to do with Qualcomm. And we work really closely with Qualcomm. Their team's great. We're optimizing with the XR2 chip. But you can imagine in the future, we'll use a lot more, in this scenario, we'll use a lot more capability of that XR2 chip.
That's what I wanted to ask, how you integrate with companies like Qualcomm, the work that you're doing to optimize the streaming. But another question that I have in my mind right now is, after ray tracing and revolutionizing the super sampling using machine learning and, of course, introducing VR, we discussed about the future of computer graphics. And during the previous conversation that we had yesterday, you told me that the next logical step for computer graphics is to become photorealistic. When can we expect photorealistic graphics in VR or eventually in video games? Something that is indistinguishable by reality.
Yeah, that's such a good question. I'm not going to give a timeline because it's just impossible, right? Because you get into a game and you go, wow, this is gorgeous. Or you get into a car scene, which I've been in a bunch of demos with cars in them to look at design software like the VRED software from Autodesk, which is, industry-wide use. And you get in there and the shaders are gorgeous and the cars are beautiful. And you go, wow, this is photoreal. This is perfect. And then you take the headset off and you look at the car and you go, okay, it's really compelling, but it's not quite there. So those finishing touches of getting all the rays cast and all the rays computed correctly, that's a lot of work. It's a lot of work. I can't imagine when it will be done.
On the flip side, I always like to be devil's advocate when it comes to this pursuit for photorealism. Is the pursuit for photorealism really necessary? For VR, do we see that as being we have to reach photorealism for VR for it to be considered something that everyone can use? Because if you look at something like how we watch, we still watch cartoons, right? But we also have real movies shot in 8K, 12K kind of things. But I guess that's just my devil's advocate kind of view.
Yeah. I think photorealism, So the way I look at it is, let's say you're simulating driving for cars, you're training the cars to navigate your world. You want them to train on the data that's closest to real life, right? You want them well trained. And so when I'm designing buildings and your living room, and I really want, or let's say a car. Let's go say I'm designing a car and I need all the reflections to work perfectly, to real life, so that when I look over in the window and I look at my mirror, my rear view mirror in the left-hand side on the driver's side in the US, there's not a reflection from some chrome part in the car that screws up my vision of what's behind me. And so those reflections have to be super accurate to make sure I don't build a car that doesn't have, vision problems for the driver. So for design and training robots and such, that photorealism is just another piece of getting the data as close to real as possible. For enjoying, experiences in VR and having a great time, Beat Saber doesn't have a lot of photorealism, but it's a great game, right? It's I don't know if it's the most popular or if that goes to Alex Half-Life, but it's certainly a great, both are fun.
It could be safe to say then that I guess that pursuit for photorealism is really for, that enterprise case study, that need from an enterprise point of view of needing that realism to be able to simulate, those environments that can be done for training and educational purposes. And then I guess that's what's driving that clear kind of force at this point in time.
Can I interject the questions? Sorry. I just wanted to add that there's a very compelling use case for photorealism that is product visualization for consumers. So if you go buy a car, you want to see the car exactly as it is in real life. if you buy a jewel, if you buy a watch, you want exactly to see the watch exactly as it is in real life. And that's why I was so excited about this next step in computer graphics, because for consumer products and for virtual stores that are becoming more and more important, especially in the post-COVID-19 era, where from digital first, the whole marketplace online is moving towards digital only, the representation of the product in the most realistic way possible is extremely important for consumers in order to drive sales.
Yeah, and if you think of cars, like we announced when we announced AWS, we announced with Lucid Motors, right? They launched their EV this year or late last year. And part of what will sell those, it's a gorgeous car on the outside. Your first surface views are beautiful, but part of what will sell those cars and be important to users is the in-cabin experience. So the buying experience that I'm going to want when I sit down and buy my next Tesla or Lucid or Rivian or whatever is I want to sit down and experience that dashboard, right? And experience because I'm not going to be driving that much, right? I'm going to become a passenger. So the real life demonstration of those interiors is going to be a really important piece of sales. So it's not only how they look, but how they function when you think of products and how we're going to explore them, whether it's a visualization 2D or in a virtual reality or AR experience. We're going to not just look at them, we're going to experience them too. And that's going to be, the more photoreal, the more representative it is, and that's going to be an important piece of the retail experiences from cars to watches. I totally agree. And then if you think of social interactions, right? If I want to have a VR pal, across the world, we're going to need to get away from these cartoon avatars and the uncanny valley avatars, and that's going to take photorealism.
Yeah. No, for sure. I can definitely always I can see the importance of photorealism in everyday kind of VR, and I think from it's definitely going to be a case that there's still going to be those elements of those environments that aren't photorealistic or things like that. For I imagine those users within VR chat, for example, where it is all about creating a whole different environment, and not necessarily the real environment. So I think there's going to be a nice mix between photorealism and
totally. Yeah. And I think back when I was at university, there was an individual in our department that worked specifically on non-photorealistic rendering, and so using things to augment the renderings that weren't photoreal, that really brought more understanding to the data. And so those techniques will be out there also. But I think of photorealism as an extender of where VR and AR are going. Not necessarily a limiter, especially in entertainment. There's tons of things you can do without complete photorealism, but to really arrive at its pinnacle, photorealism is going to be in my mind, is going to be an integral part.
Imagine during COVID a tool that will allow you to be a virtual tourist in photorealistic environments all around the world. A little bit like Google Earth, but completely photorealistic.
Yeah.
Yeah, I can also, on the flip side, I can see, going out with my AR glasses, someone with one of those anime Snapchat filters, and I'm walking down the street and that's how that person looks to me. So yeah, I can see a mix. Yeah, it's awesome.
It's very Roger Rabbit, but you're probably too young to remember that movie.
To put everybody, I can't remember the latest anime thing where the giants eat people. But that might be a world that would be fun for a few minutes to run around in, right?
Until the giants get you.
Until the giants get you. Yeah, to put those kind of characteristics and build up the flavor of a scene is going to be a big part of VR also, I think.
Brilliant. Greg, thank you so much for being with us. This has been enlightening, and so we really, really enjoyed this conversation.
Yeah, it's been a pleasure. Thanks for chatting and we've created a future for VR and XR, so hopefully my engineers or the NVIDIA engineers don't listen to this and come back and ask why I promised all this stuff. But other than that, I think this was great.
I've certainly, I came into this thinking I knew a lot about CloudXR, but I've come out of it now realizing I have a lot more to learn and a lot more to kind of look up as well.
Oh yeah, I'm anxious to get it into your new place, right? So we can experiment with it.
Greg, would you like to give the CloudXR website to all the developers and people that would like to experiment with the technology?
Or any of the tools as well?
Yeah, I think if you just search for Nvidia and CloudXR, it'll be a link. It'll be the top link you see.
Yeah, we'll definitely as well. When for anyone watching this or listening to this, like we're at the process of testing out some of this CloudXR technology within AIXR's offices as well. So as soon as we get some of those things that we can share with you, definitely keep an eye out on our social medias and on our kind of tours. We'll be putting together a really cool video on that and how it works within our kind of spaces as well. So yeah, definitely take a look at that as well if you're interested.
Yeah, and we're starting to develop an ecosystem that's expert in CloudXR. So, there's companies like the Grid Factory who you're working with that we can certainly turn people on to help them in their CloudXR journey, right? So it's exciting times, really exciting times now that we're starting to stream XR.
Fantastic. Can't wait to see how it develops. Thank you so much, Greg, for being with us. And please.
Thanks for the invite.
Absolutely, absolute pleasure. And please, everyone, don't forget to subscribe to the channel. And we'll catch up in about 3 weeks from now with another episode of Field of View. I'm Nick Rosa from Accenture.
And I am Daniel Colaianni from AIXR.
Thanks for being with us.
Through accessible insights, a solid network of support, and recognizing truly outstanding achievements near or far. Big or small, we're in this together. AIXR.